Take a look at some more examples at integrating inverse trig. So let's say we had the integral of dx over the square root of 4 minus x squared. So just like before, if it's a polynomial denominator, complete the square, but if not, ask what it looks like. So looking at all the options that we have, it looks like that. So we're going to write that down. So the integral of 1 over the square root of a squared minus u squared du is arc sine u plus c. And the key is to make it look like that. So factor out the denominator if a is not equal to 1. A is not equal to 1, so we do need to factor it out. So how do we factor that out? We'll take out 4. If we take out 4, what's left? 1 minus and then x squared over 4 because we've taken out 4. Now, I'm just going to show you this with numbers, then do it with this. If you had the square root of 16, you know it's 4, right? Which is 4 times 4, which you can rewrite as the square root of 4 times the square root of 4 because that's going to be 2 times 2, which is equal to 4. So it's the same thing. So I can rewrite this as the square root of 4 times the square root of the parentheses. This is a listening check. Circle example 2. Once I know that, I can take the square root of 4, which is 1/2, put that outside, leave everything else inside, and now my a is equal to 1. So once my a is equal to 1, I can rewrite it squared terms. So u squared is equal to x squared over 4, which means u is the square root of both top and bottom, which is x over 2. And a squared is equal to 1, which a is equal to 1. That's perfect. So you got 1/2 is the square root of 1 squared minus u squared, which is x minus 2 squared. X over 2 squared, I'm sorry. And then dx. Find du in terms of dx and make it look like what you need. So du is equal to 1/2, because x just goes away, dx. And that's what I need, actually. So I've already found out what I need. Rewrite the integral in terms of u and du. So the integral of 1/2 dx is going to be du over the square root of 1, because 1 squared is 1, minus, and then that is u squared, because u is x over 2. Alright, so that looks exactly like that. So now we can say that the integral of that is arc sine u plus c, and u is equal to x over 2 plus c. That's pretty much it. So take a look at another example. If it's not a polynomial on the bottom, alright, just go to straight asking which one does it look like. So that one looks like this. So we're going to write that down. And that's equal to arc secant u plus c. So we need to make it look like that. Alright, so factor out the denominator of a is not equal to 1, which it's not equal to 1, it's equal to pi. So let's factor out pi. That leaves x squared over pi, because they didn't have it. And then we take the pi out of there, it's been 1, no, negative 1. So that's going to be the same as the square root of pi x, and then the square root of x squared over pi minus 1. This is a listening check, box example 3. So u squared is equal to x squared over pi, which means u is the square root of x squared, which is x, and the square root of pi, which is square root over pi. And then a squared is equal to 1, and that means rewrite it as squared terms. So it's going to be 1 over square root of pi outside, and then that's x, and then the square root of u squared, which is x over radical pi squared, minus a squared, which is 1 squared, and dx on top. Alright, then find du and make it look like what you need to in terms of dx. So du is equals to 1 over radical pi, which is going to be a straight up substitution. So write the integral which is going to be du, because all that has become du, over x. So I need to find what x is. Okay, so all I have to do is multiply both sides of that by radical of pi, which is going to be radical pi u equals x. So that's what I'm substituting x as. So x is radical pi u, and then the square root of that, which is u, so that's u squared minus a squared, or 1 squared. Alright, and that looks just like that with the exception of that radical pi, so I'm going to take that outside. So now that looks exactly like that, which means that's arc secant u. So this is going to be 1 over radical pi, arc secant u plus c. Alright, substituting u back in, it's going to be arc secant, and u is x over radical pi plus c over radical pi. Or you could rewrite this, because you don't like radicals on the bottom, is multiply top and bottom by radical pi, and you're going to get radical pi arc secant of x over radical pi over, then radical pi times radical pi is just pi. So either answer should be okay. but I don't like radicals on the bottom. All right, let's take a look at another example. This is a listening check. Underline example 4. All right, so we finally got one which is a polynomial. So you need to complete the square. So it's a polynomial in the denominator, you complete the square. So write it all out. Remember, if a is not equal to 1, you have to divide by a. So in this case, it's a negative. So divide everything by -1. So you're going to get x squared minus 4x plus 3. That's your new problem. So remember, skip a line. For label ABC, don't forget the symbol. Then skip a line, and you're going to write x squared and then plus c outside, which is positive 3. You're going to take half of b, which is going to be -2. And then you're going to square it and put it on top. That's plus 4 and then minus the 4. You should be good at this by now. The first 3 terms are that. That one is that. So the only thing missing is the -4. So you're going to get x minus 2 squared. And then 3 minus 4 is -1. All right, so we're going to rewrite that polynomial like this. This is a listening check. Colleen, complete the square. The sentence, complete the square. And then let's see what that looks like. That looks like the arc sine of u. So I'm going to write down what the formula is. The only thing is, though, a squared is supposed to be first, and then the variable is supposed to be negative. But in this case, the variable is positive. So I'm going to rewrite that by multiplying everything by -1. All right, and I'm going to do it here on the side just to make sure that you understand what I did. So again, multiplying everything by -1 will just change the signs on each thing, making it that. Which means I can rewrite this now as that being positive and the variable being negative, which is what I need. So it's the same thing. All right, so u squared is equal to x minus 2 squared, which means u is the square root of that, which is x minus 2. A squared is equal to 1, which means a is equal to 1. Find du. Du is the derivative, which is just going to be dx. And then rewrite that in terms of that. So du is just straight up replacing dx. And then there we have 1 squared minus, and that whole thing is u, so u squared. Now that looks exactly like what I need. So that's going to be arc sine u plus c, and then replace u, which is x minus 2 plus c. And that's pretty much it. Okay, we're going to look at 2 different examples. Now that we know this, we can use the inverse rules to find the derivative of inverse trig functions. So now that we know this, we can use the inverse rules to find the derivative of inverse trig functions a little bit faster than actually working it all out. All right, pause the video and copy that down. And check, color in that whole paragraph with steps 1 through 4. All right, so let's take a look at an example. Let's say we have 1/4 inverse tan of x over 4. Find the derivative of that. So using the derivative formula, we need to write the rule down for that inverse. So inverse tan is 1 over a squared plus u squared du, and you should know these by now. If not, you need to memorize them. All right, what is u? U is x over 4. And that means that du is 1 over 4. So then the derivative so replace the function. So then the derivative of 1/4 inverse tan of x over 4 is going to be the 1/4. And then the inverse term is going to be replaced with the shortcut formula, which is that. So that's going to be 1 over a, which is 1 squared, plus u, which remember is x over 4. So u squared is x squared over 16. So x squared over 16 times du. And what's du? Du is 1 over 4. So times 1 over 4. And then we're just going to do some algebra. All right, so let's make the denominators the same. Oh, let's combine the 1/4 actually. So that's going to be 1 over 16. Then make the denominators the same. That's going to be 16 times the top 16. So we're going to get 16 plus x squared all over 16. Now keep, change, flip, or sandwich, however you want to look at that. That's going to be 1 over 16 times 16 over 16 plus x squared. Those 16s are going to cross out, or they simplify. And then that leaves 1 over 16 plus x squared. And that's it. All right, let's take a look at one more example, make sure that you understand this. So find the derivative of the inverse sine of 1 over x. So again, write the rule for the inverse. So for the sine, it's going to be 1 over the square root of 1 minus u squared. What is u and du? U is 1 over x. So du has got to be negative 1 over x squared. And if you don't remember that, just take the x to the top, then subtract 1. Bring the power down, subtract 1. Alright, then so the derivative of the inverse sine of 1 over x is equal to, there's nothing there, so that substitutes to 1 over, and we got 1 squared is 1 over x squared, because you square the top and the bottom, times du, which is negative 1 over x squared. Alright, let's clean this up a little bit using some algebra. So negative 1 over x squared, and then we're going to make the denominators the same in this radical, multiply top and bottom by x squared. So we're going to get x squared minus 1 over x squared. Okay, and I kind of made a mistake and cut this off, so I'm putting it back and just going to explain it. So this is what we have. We can separate the radicals differently, and then once we separate the radicals top and bottom, we can go ahead and simplify. The square root of x squared is x, but you're going to put absolute value, which is going to cancel with the x squared on the top, which leaves the answer. It's not very difficult, but you have to memorize some stuff. So let's practice.